Hello, and welcome to Backer Breaks It Down. And in this episode, we are going to find some values of inverse trig functions. So this little snow angles comic is illustrating two notations for inverse trig functions. So the one that you will see most often is the -1, kind of looking like a little exponent. That's the inverse notation that is on your calculators. Like you've got a button on your calculator that looks like this, x to the negative first power, and that's like your inverse button, right? We have previously used an inverse trig function to find angles. So when we were like solving right triangles with like SOHCAHTOA stuff, or even like we found angles using law of sines and law of cosines, we were using an inverse trig function. So it's like we know that the result of using an inverse trig function is an angle, okay? Another notation just to be aware of is the use of the term arc followed by the trig function. So here we have arc sine of 1/2. And honestly, it would mean the same thing if I just simply did like sine with the -1 exponent of 1/2. So arc sine and inverse sine of 1/2, we're talking the same thing. Two different notations though, okay? All right, so when you evaluate an inverse trig function, your answer is going to be an angle. However, like our domains are restricted, okay? Like our calculator, if we use inverse sine, like if I were to go back to the snow angles thing, and if I did the inverse sine of 1/2, my calculator will tell me it's like 30 degrees. Otherwise, like it would give me like a really weird decimal to represent pi/6 in radians. If I did arc sine or inverse sine of -1/2, all of a sudden my calculator is telling me it's like -30 degrees, which is -pi/6 radians. And it's like, well, why is it doing that? Okay, and I'll tell you why it's doing that. Our calculators are programmed to follow these rules here. So when I use inverse sine, my calculator is going to give me an angle found between -pi halves and +pi halves. Okay, so it's giving me an angle in between -pi/2 and +pi/2. So it's giving me an angle in quadrant 4 or in quadrant 1. Okay, so if I'm finding like the inverse sine of a negative exact value, then my calculator gives me that angle in quadrant 4. And if I'm calculating the inverse sine of a positive exact value, it's going to give me that angle in quadrant 1. And it's going to do the same thing for tangent, okay? So if you have inverse tangent of a positive number, your calculator will give you an angle in quadrant 1. And if it's the inverse tangent of a negative number, it'll give you an angle in quadrant 4. Now, we are not calculators, so like when we as humans without a device is doing this, we are going to be working with radians. And the nice thing about quadrant 4 and radians is it's just the negative version of it. So like pi/6 in quadrant 1 would be -pi/6 in quadrant 4. So quadrant 4 is really nothing to really fear. Inverse cosine, if you use the calculator and you calculate like inverse cosine of +1/2 and then inverse cosine of negative 1/2. The positive 1/2, you're once again getting an angle in quadrant 1. So basically, anytime you're calculating an inverse trig function of a positive angle, the answer will be an angle in quadrant 1. For inverse cosine, when you calculate, like I did inverse cosine of negative 1/2, I got a measure of 120 degrees. So that's in quadrant 2. So if you calculate the inverse cosine of a negative number, you're going to get an angle in quadrant 2. Okay, so you will need to think like, what is the radian measure of an angle in quadrant 2 with a reference angle of 60? So quadrant 2 can be a little tricky, but like, it's not as bad as you're thinking it's going to be. So basically what we're seeing here is that there are no inverse trig functions in quadrant 3. Okay, so in order to do an inverse trig function problem, you want to think about the quadrant that it'll be in. So like I'm looking at number 3. And number 3 says inverse tangent of the square root of 3. So when it comes to like what quadrant am I in? Well, it's inverse tangent of a positive number. So if it's a positive number, that means I'm in quadrant 1. And like I can even like sketch for myself what that would look like. Tangent is the opposite over the adjacent. So like the opposite would be the square root of 3 and the adjacent would be 1. So the opposite is the square root of 3. The adjacent is 1. And remember, in all of our reference triangles, the hypotenuse is 2. Okay, so we have to be like, well, what's our reference angle? What is the square root of 3 opposite of? And so if you look at our 3 reference angles, opposite the 30 is 1. Opposite the 45 is the square root of 2. Opposite the 60 is the square root of 3. Okay, so for this one, we're talking like a 60-degree reference angle in quadrant 1. And so a 60-degree reference angle in quadrant 1 is equal to pi over 3. So that would be my answer here, because the inverse tangent will be an angle found in between negative pi over 2 and positive pi over 2, meaning quadrants 4 and 1. Since it's positive, it's in quadrant 1, and according to the exact value, that would give me a reference angle of 60, which is pi over 3 radians. Okay. Inverse cosine, that one's kind of weird just because it consists of like quadrants 1 and 2. So I'm just like kind of jumping around here. I apologize for that, but I like these visuals. So number 5 wants us to find the inverse cosine, okay, of negative square root of 2 over 2. Okay. Sorry, I don't know why my stylus sometimes doesn't want to work for me. Okay. So it's inverse cosine and it's negative. So what I know is that inverse cosine is negative in quadrant 2. So it's going to be one of my quadrant 2 angles here. So I can kind of on my paper sketch out cosine. I mean, I know, you know, cosine is the adjacent over the hypotenuse. So like the adjacent here would be the negative square root of 2, and the hypotenuse is always 2. So we're talking like this is our reference triangle. And going back, you know, here are our diagrams. What's the reference angle? Yeah, the reference angle is 45 degrees. Okay, so I want to find the angle in quadrant 2 with a 45-degree reference angle. So that would be this one right here. Okay, my 3 pi over 4 would be the answer that I would write down as my final answer, because when we find and evaluate these inverse trig functions, our answer is an angle in radians in the appropriate quadrant. Okay, so we need to ask ourselves, okay, what quadrant is my answer in? We need to know, like, what is our reference triangle, and then we can find our answer angle. Now I want you to be aware of zeros and ones, because if you encounter a 0 and a 1, you're at a quadrantal angle. So just remember, at those quadrantal angles, you've got ordered pairs, all right? And in those ordered pairs, cosine is representing x, sine is represented by y, tangent would be y over x. So whenever you encounter a 1 or a -1 or a 0, you are working with a quadrantal angle. I want you to use this diagram, okay? So looking at these examples, we already did number 3. So remember, for number 3, we got pi over 3, and we've already done number 5. We got 3 pi over 4 for number 5. So let's check out these other 3 examples. So number 1 says sine of 0, and that 0 gets me to 0 in on my unit circle. Since we're working with sine, what do I know? I know that sine of theta is equal to y. So 0 is a y value. Now remember, my answer to an inverse problem is an angle whose measure is in radians in the respective domain. So for sine, we're talking quadrants 2 and 4, right? So I want to look, kind of limit myself to those areas. And I want to look on my unit circle for a y value of 0. So we're talking these values here. So I'm seeing a y value of 0 here at 0 radians. Okay, so inverse sine has a value of 0 at 0 radians. Okay, so let's try another one. Another quadrantal problem. So problem 2 is asking about inverse cosine of -1. So -1 alerts me to my unit circle. Cosine is represented by the x values on my unit circle. Inverse cosine happens in quadrants 1 and 2. So that's where I want to look for this. So the -1 is an x value. So I want you to find where is the x value equal to -1 on your unit circle. That's equal to -1 right here. And what is the value of that angle in radians? Yeah, that would be the pi radians. Okay. Number 4 says inverse sine of -square root of 3 over 2. So I want you to first think proper quadrant. What is that? Well, inverse sine is negative here in quadrant 4. So I'm going to sketch for myself this triangle they're describing in quadrant 4. I know sine is the opposite over the hypotenuse. So I know the opposite would be this -square root of 3, and the hypotenuse is 2. So I want to think about what is that reference angle? So I'm looking at a 60-degree reference angle, which is also pi over 3 radians. So here in quadrant 4 is a nice quadrant. All I have to do is negate that. So negative pi over 3 would be my answer. Right? Now there are these other problems that you can do that involve composite trig functions. So notice in number 6, we've got cotangent, and then inside we have inverse sine of -3/5. Believe it or not, these problems I think are a little bit nicer. Okay, we just need to realize that the inside part of this composite function is an angle, so it's theta. And we can totally sketch theta, a reference triangle, in the proper quadrant. So inverse sine is negative, has a negative value like that in quadrant 4. So I'm going to draw quadrant 4. And I'm going to label my sides. So like I know sine is the opposite over the hypotenuse. The opposite is -3 and the hypotenuse is 5. And then I'm going to use my good old Pythagorean theorem to figure out what is x. Okay, because x squared plus -3 squared is 5 squared. So I'm doing all this math. And I ultimately discover that x is 4. So now all 3 sides of my reference triangle are represented. Check your signs, right? That's a good time to do it. And then the only thing left for us to do is to evaluate, like, what is cotangent of that angle? So cotangent of our angle, cotangent would be the adjacent over the opposite. So -4/3, and that's your answer. So inverse trig functions, like, it all comes down to the proper quadrant. When you have the inverse trig of a positive value, your answer is an angle in radians in quadrant 1. If it's inverse sine of a negative value or inverse tangent of a negative value, then it's an angle in radians in quadrant 4. And if it's inverse cosine of a negative value, then it's an angle in radians in quadrant 2. And that's how Backer breaks it down.